And welcome to this keynote session, forming part of the 11th Annual Analysys Mason Telecoms Summit. My name is David McElroy, and I work as part of Analysys Mason's online events team. Now, you may have already watched some other sessions leading up to this one. However, I just wanted to remind you of a few points that will help you to get the most out of this and all other summit presentations. Firstly, please remember that all sessions are available on demand, meaning that you can access them, watch them, re-watch them in a time and in an order and at a date that suits you. As well as this presentation, we also have a selection of other keynote and breakout sessions from you to choose from, and you can access all of them via the event homepage. In addition to our keynotes and breakout sessions, we also have a panel session on 5G, so please be sure to check that out. Now, once you have entered your chosen session, you have the ability to connect with and contact the presenters. You'll be able to access some useful resources and submit questions. Please use the console widgets to do all of those things. Now, in terms of the questions, because these are on-demand sessions, our presenters will pick up your questions and then respond to you directly by email in the coming days. And once the session has ended, you'll be automatically redirected to the event homepage, and you can also access the event homepage at any time by clicking the event homepage button. Now, I have the pleasure of introducing two colleagues of mine. First of all, we have Research Director Caroline Chappell, and then we also have Research Director Caroline Gabriel. So I think Caroline Chappell will be kicking off the session. So Caroline, I'll pass over to you whenever you're ready.
Thank you very much, David. Hello, and welcome to the Analysys Mason Summit 2021, and to our presentation, the 5G Network, an experiment with a $300 billion prize. I'm Caroline Chappell, Research Director responsible for our Cloud and Platform Services programs, and with me is my colleague, Caroline Gabriel.
Yes, hello, I'm Caroline Gabriel. I'm the Research Director with responsibility for our Networks practice and for our Operator Investment Strategies program.
So in the next 30 minutes, we will attempt to answer 3 questions that telecoms operators are grappling with today, and I will get those questions up in a minute. What is the business case for 5G? Much is being promised about the ability of the 5G network to tap into new sources of revenue and to deliver new services. But this is still unproven. Will the experiment be worth it in the end? The 5G network is the first telecoms network that can be built using so-called cloud-native technologies, technologies that are very different to those that have underpinned the network for decades. How will this change prepare telecoms operators to remain relevant in an emerging world of services driven by IoT, AI/ML, and edge cloud? And finally, how can operators ensure that despite the experimental nature of the 5G network, they'll successfully implement it and put themselves in the running for a share of the $300 billion worth of additional revenue we estimate will be on offer? All very big questions, of course, and as our time is limited, we'll only be able to address them at the highest of levels. But we hope that our thoughts will stimulate a debate that we would be happy to continue with any of you after the summit. So over to you, Caroline, to look at what's at stake financially in this 5G experiment.
Thank you, Caroline. Simply put, as Caroline just said, what's at stake here is almost $300 billion. Our colleagues in Analysys Mason Consulting recently modelled the increase in GDP that would be directly enabled if new open cloud-based networks for 5G were deployed globally by 2030. That amounted to actually $284 billion US cumulatively between 2021 and 2030. This is, by their modelling, generated in 2 ways. $105 billion is enabled by dramatically increased access to mobile broadband that will be available to all and of a high quality. Meanwhile, $179 billion will come from higher usage enabled by flexible service platforms, flexibility that will support thousands of interconnected services and users. A smart city, as depicted here, is a good example. Not since the Industrial Revolution or the advent of the Internet has new technology been directly responsible for such leaps in wealth and revenue opportunities. The new cloud-native architectures, hyper-connected by 5G, can enable new revenues in every industry. And because the connectivity is critical to the platform, operators have the opportunity to capture a significant share and to play various roles in the value chain. Much more of all that later, but I'll now hand back to Caroline to discuss how these new revenue streams may flow through 5G.
Thank you, Caroline. Well, we can speculate endlessly on the use cases that will drive 5G service revenues. We're continuously researching 5G and multi-access edge computing use cases, and one thing is for sure, there are a lot of them, and no one service is likely to be the killer app that generates the lion's share of service revenue. But broadly speaking, there are two kinds of use cases that people will pay for. Those that optimize some kind of process so that it can be done better, faster, cheaper, and those use cases that delight customers with a novel experience. These motivations, and apologies again, I think we're on the wrong slide there we are. Those motivations remain just as true for use cases, for future services that will involve 5G as they have in the past. What does change over time are the technology enablers of process optimization and new customer experience. You can argue about what the most influential enablers are likely to be over the next decade, but it's clear to us that the increasing amounts of data produced and consumed by more and more connected things will be important, whether that's to the accuracy of an optimization or to the realistic nature of a new experience that's delivered in the digital world. AI/ML technology will be a further key enabler that turns data into intelligence far more quickly than humans can, and which will replace manual steps that introduce friction into processes and experiences. The net effect of more data and the application of AI/ML to it will be the better optimization of those processes and experiences with all the beneficial effects that optimization brings, such as cost reduction, improved customer loyalty, better supply chain resilience, and even the biggest goal of all, sustainability. As growing amounts of data need to be processed, machine learning models are trained, and ML inference algorithms are distributed widely, they'll require increasing amounts of cloud compute, storage, and connectivity. We're seeing an accelerated build-out of cloud data centers across countries and cities as demand for public cloud resources continues to soar. And of course, 5G is designed as a high-capacity network that can provide a direct on-ramp to distributed clouds as these are deployed, either on enterprise premises or in a service provider's network. The demand for more bandwidth to transport more data will contribute to the growth in mobile broadband spend that Caroline has just mentioned. But the key to 5G's ability to generate revenue from services is that it's the first telecoms network that can run in the cloud on an equal footing with emerging cloud-native IT applications. The 5G network and the cloud are software-defined infrastructures. They're being built on the same software foundations as IT applications themselves, and they can be manipulated and programmed like IT applications. The convergence of software-defined cloud infrastructure and applications is a momentous enough development for the IT world. It's spawning change and disruption in every industry, not just in telecoms. But it becomes even more far-reaching in its implications when the network itself is made of microservices that can be spun up and managed like applications, co-located with them, and able to interact directly with them through APIs. This convergence between network services and application services would enable innovative combinations of both. And the thesis behind the 5G experiment is that this will result in new categories of digital services we haven't seen before, which new ecosystems can monetize. But there is a second reason why Caroline and I think the 5G experiment is so significant. If operators can master a programmable, software-based 5G network, they'll be better placed to provide the software-defined connectivity that will become an integral feature of a digital service in the future. Note, I said software-defined connectivity would be a feature of an application or digital service, not a transport underlay or a slice or in any way external to the service. Network functionality will be integrated with the business logic of applications in specific combinations, depending on the application's connectivity needs. The network's ability to peer with applications will be needed not just in the mobile network, but in all other telecom network domains in future. It's simply that the software-defined capabilities that underpin this concept are emerging first in 5G. 5G therefore prepares operators for the changes in networking in general to support the next wave of cloud and AI-based IT transformation that's expected over the coming decade. Now let's see if I can turn onto the right slide this time, because it's an incredibly sensitive button. But here I am on the right slide. The value of the 5G network's software-defined capabilities is not immediately obvious yet, because the market is still in an era of early cloud. The cloud has been developed as the most efficient way to execute web applications with three-tier architectures: a presentation tier, which is a relatively dumb user interface; the application or logic tier, where all the application intelligence sits; and the data or storage tier. The application and storage tiers sit in the cloud, and a dumb pipe connection links the presentation tier on a user compute device to the cloud. This application architecture has been around for 15 or so years now, and the 5G network really doesn't have much scope to play here except as a faster transport mechanism for connecting the presentation tier of an application to the nearest fixed point of presence to the cloud. This is still the case even when we look at the current generation of distributed cloud, where the major public cloud providers are co-locating their public cloud stacks in metro data centers owned by telecoms operators. Here, public cloud providers are simply using operators to distribute their presence to more locations, mainly in response to enterprise concerns around data compliance and data backhaul costs. Nothing changes in terms of connectivity, which remains a dumb pipe, and not necessarily even a mobile dumb pipe, as Lumen, Colt, Equinix, and other service providers addressing the distributed cloud market prove. Now, the interesting development in cloud-to-cloud or inter-cloud connectivity doesn't concern the 5G network at all, but it does start to showcase the power of a cloud-native approach to networking, which the 5G network embodies. Various startup service providers and entrants from the IT world are building overlay networks that connect applications running in different public cloud provider clouds to each other to fulfill user requests. Operators tell us that large enterprises now run applications in an average of 4 different clouds, which they then need to connect across multiple clouds to carry out their business processes. Such overlay networks are software-defined. They can be spun up on demand in different clouds and data centers to provide optimal routing paths for a specific application. And depending on the application's needs, they can orchestrate security, performance optimization, and other cloud-native services into the path of the application as it traverses the public clouds. Increasingly, such overlay networks are procured by application developers, not by enterprise networking departments. DevOps teams want to add overlay connectivity into their continuous integration, continuous deployment, or CI/CD pipelines, so that they can spin up cloud-native applications, cloud infrastructure, and cloud-native connectivity at the same time. Now, we know from our research that advanced operators are struggling to put CI/CD in place internally as part of their cloud-native 5G implementations. But the only operator currently saying it's prepared to give enterprise application developers CI/CD access to its 5G network is Dish, which has a highly ambitious strategy to support hundreds of thousands of application-specific network slices with thousands of different parameters, which will stretch the cloud-native capabilities and application network convergence potential of the 5G network. Dish's vision will be needed, not just across the 5G network, but across all network domains, as enterprises seek to connect cloud platforms that will spring up in millions of locations globally over the next decade, as this slide attempts to illustrate. I've already talked about the trend towards the greater distribution of public clouds to metro locations, but cloud technology is moving on-premise too, not to large central enterprise data centers, but to smaller sites and branches to run semi-autonomous operations and to enable application integration and more efficient utilization of server resources at individual branches or sites. I was told recently about one of the largest US coffee chains, which has centralized all its applications in the public cloud, only to find that when the connection to a branch goes down, it can't sell customers a cup of coffee. It's now in the process of repatriating application functionality as close as possible to the customer so that its branches can operate autonomously and offline if they need to. Quick service restaurants have resisted the move to public cloud because they rely so much on on-site technology, from cameras that gauge the length of drive-in queues, to menu systems that simplify themselves when demand is high, to intelligent ovens that recognize hundreds of barcoded food items, to robotic chefs. However, each of these systems requires a dedicated server to run on-premise, and integration costs between systems are high. QSR chains are in the process of replacing discrete servers with cloud stacks on-premise to run any application they need now and in the future. And we're seeing the same pattern repeat itself across industries, from intelligent buildings to manufacturing, where embedded software in industrial systems is being disaggregated from proprietary hardware and rewritten as microservices that can run in containers on on-premise distributed cloud platforms. Does that sound familiar, telecoms operators? This makes integration between local devices and the logic that controls them easier, for example, between industrial robots from different suppliers in a production line. But let's take the future a step further, as visionaries imagining new customer experiences and AI-driven process optimizations are. Suppose the systems in a QSR, suppose the cameras in a QSR are connected not just to cameras on their premises, but traffic cameras in its city, so that a drive-through restaurant can detect and predict the time of arrival of its customers before they turn into their forecourts and have their order ready and waiting, subject to its customers allowing their number plate data to be passed to the QSR chain, of course. Supposing a manufacturer can be alerted to customer events and/or supplier inventory changes that enable it to retool its production line in minutes to respond. At a recent Bosch event, Sebastian Thrun of Udacity compared such scenarios to Harry Potter's Hogwarts, where everything talks to everything else and things happen magically, a rather wonderful analogy for what he calls an AI of things future. And it is these kinds of AI of things scenarios, already being imagined for smart cities, by the way, that will create new customer experiences and levels of optimization that people will be prepared to pay for, driving the new service revenues we've been talking about. Now, the problem is that the current state-of-the-art integration between web applications talking across dumb pipe networks and distributed clouds doesn't support AI of things scenarios. My team at Analysys Mason has coined the term edge native to describe the environment that will support Thrun's AI of things. In an edge native environment, location matters. Edge native cloud platforms need to be available in every conceivable location so that data can be processed close to where it's needed, not just in a few thousand distributed cloud data centers globally. A whole new class of data and event-driven applications is emerging that will depend on the existence of this seamless fabric of edge-native clouds to execute. This category includes AI applications, computer vision, natural language processing, blockchain, automated guided vehicles, and applications that support collaboration across multiple contexts and devices, such as multiplayer AR gaming. Such edge-native applications are being developed using a very different architectural approach from web applications. They're based on event flows and highly reliable scalable messaging, not client-server request responses. IT visionaries, including Tim Berners-Lee, expect such an architectural approach to become key to application development over the next 15 years. Now, flow-based applications are made up of multiple different containerized business logic components distributed across many different clouds, but which connect with each other and cooperate together in response to external events using a publish and subscribe model. It's very difficult visually to present the dynamic dynamic nature of a flow-based architecture and the dynamic composition and recomposition of flow-based applications. Again, I go back to Sebastian Thrun's Hogwarts analogy, or a smart city, where everything is an autonomous system that watches everything else and can shape-shift and move in response to everything that's happening around it. But the important paradigm change to note here is that while web application architecture is cloud-centric, a flow architecture is network-centric. In a flow architecture, the network is the critical connector of microservices into application pipelines, which determine the way in which data is processed locally and simultaneously across clouds. The network is a peer facilitator of the pipeline, not just a dumb pipe. It determines which microservices locations should be connected to complete the pipeline based on its end-to-end understanding of the properties and resource profiles of those locations, how to connect them securely, and the network can even provide compute locations for pipeline components to use. The edge-native vision is nascent today. We're at the very beginning of what will probably be a 10 to 15-year journey towards flow architectures becoming mainstream. The technology that underpins them needs to mature and become widely adopted, and the companies need to invest in building the use cases they support. The director of technology for a Fortune 50 insurance company told me last year that he understands how AI-based computer vision and natural language use cases supported by edge-native clouds and 5G would allow his company to reimagine the customer experience it can offer. But he finds it hard to explain this brand new art of the possible to his board in ways that they will understand and sign off on. And all the while it's difficult to identify and build business cases for edge-native use cases, there'll be reluctance to build out edge-native infrastructure. There'll be a natural inclination to play it safe and stick with distributed cloud. Except that operators already have the best use case that exists today for the building of edge-native clouds and the incentive to build the kind of edge-native connectivity that will be needed for flow architectures and applications in the future, the virtualized RAN. And this is why we're arguing that if operators deeply master the software skills needed to build the 5G network, and the right mindset and culture, they will be well prepared to build end-to-end networks beyond mobile that can support the edge-native developments of the next decade. If they don't, the edge-native network of the future will still materialize, but as an overlay network. Operators will merely provide dumb infrastructure, while others go over the top with stateful connectivity and orchestration. In fact, VMware, in a recent briefing on its new cloud strategy for the edge, called the 5G network an underlay network, assuming that application pipeline connectivity would be provided by its own overlay, SD-WAN, SDN, and service mesh products. Now, since a 5G network is software-defined and will incorporate service mesh technology, the question I have is, why allow it to be disintermediated by IT overlay vendors? So back to you, Caroline, for your thoughts on what operators need to do to maximize the success of the industry's big 5G experiment.
Thank you, Caroline. As Caroline just outlined, there are huge challenges for those operators that do choose to seize this vast opportunity and establish themselves as the key enablers of an edge-native world in which the network becomes a connector of a limitless combination of microservices. The architecture that Caroline has described is clearly transformative and has the capability to enable huge revenue growth for operators and many others. But if operators are to maximise their share of those new revenues, they need to recognise that this architecture represents a radical change on multiple fronts, and one that remains a big experiment whose outcome will not be fully visible for a decade. What is an experiment? The Oxford Dictionary definitions are quite helpful. A test, trial, or tentative procedure for the purpose of discovering something unknown or of testing a principle. A scientific test that is done in order to study what happens and to gain new knowledge. This doesn't sound at all like the conventional telco approach, in which large-scale rollouts come once most of the outcomes and risks are well understood. This is not 4G. Then there were changes, certainly, to the network architecture, but the business case, service model, and telco organisation remained fairly similar to before. There might be uncertainty about the degree of the impact on the business, but not the way that impact would come about. The same was true of the first phase of 5G, which was deployed to enhance 4G mobile broadband capabilities. But if 5G is to be an essential part of this new architecture and deliver significant shares of the spoils to operators, there must be a complete rethink. Experiments must be made with the results not certain up front. Instead, there will be a continual process of testing different combinations of technologies and services. The results must be examined, knowledge gained and expectations amended. As in any experiment, multiple processes must be tested to understand their impact on one another. The control experiment, at the bottom of the test tube here, is to stay with a conventional network architecture and a conventional connectivity model, which many operators will do. And that will be a successful route for some operators if they focus on differentiated quality of experience or pricing, increase their wholesale or their fixed mobile revenues, and moderate their growth and profitability expectations. But if operators want a significant piece of that $300 billion, they need to take the plunge into the edge-native world Caroline has described. That will require a full re-evaluation of every aspect of their network strategy, their business model and their organisation. And this is not a challenge to start to be addressed in a few years' time. Our surveys of operators, which we conduct on a very regular basis and at a very high level, often reveal caution not about the new architectures, but about when to start planning for them, when vRAN platforms are mature, when 3GPP release 17 is finalised, when there's clear demand for ultra-low latency services. The list of reasons to prevaricate is long, and most of them rely on someone else doing something. But while most non-greenfield operators will not emulate Dish's approach today, to have a good chance of a pivotal role in the emerging value chains, they need to start laying the foundations today and to take responsibility for their own future success or failure. There are three main areas in which they must examine current practice and be prepared to make significant changes with the outcomes not entirely known. Those are summarised on the slide. They are the ecosystem and the operator's role. What's the optimal role for you in the value chain, and what partnerships are required? Asset ownership and investment. What assets to invest in directly, and which do you really need to own? And organisation and culture. What are the skills and the organisational structure that will best deliver the strategy? We'll look at each one in more detail, but the point to stress is that each of these areas needs to be transformed in parallel, and that requires making plans and decisions now in a holistic way. For the experiment to work, the operator must first decide on its preferred role in the emerging value chains and the ecosystem that will require. In this fluid environment, we've identified three broad roles that the operator can take in the value chain. It can be the connectivity provider, as you see at the bottom. High-quality connectivity with associated network services, such as security and device management, is of course critical to provide the mesh to tie the clouds together. Some services will require very specialised connectivity, including ultra-low latency, levels of uptime that can be guaranteed, support for many thousands of sensors or devices within a small area, and so on. All these are difficult to achieve, and operators that offer such capabilities directly to customers or to the platforms that are orchestrating connectivity from many sources will have clear differentiation and prevent their networks being commoditized. It's also the layer where the operator will have home advantage. There are new entrants, enabled by developments such as shared spectrum for 5G, that will build connectivity, but operators understand best how to build, optimize, and monetize networks. If the world stayed with the first generation of cloud models, as Caroline told us, this would remain the most attractive model for most operators. However, in the hyperlocal edge-native platform, with its vast array of interlocking services, connectivity will only represent about 10% of the total value of the services market in the period to 2030. Far bigger opportunities lie further up the stack. Platform providers can capture around 40% of the new revenues that will be generated in this period, while service providers can address 50% through the huge wealth of different applications and services that will emerge across different geographies and industries. In the past, the operator's business model has been fairly clear, as we say. Most operators have remained heavily focused on that connectivity layer and on differentiating themselves there. Some have tried to move up the chain into offering applications, digital services and platforms, though successful examples are relatively rare, even in the more limited context of the 4G world. SK Telecom, NTT Docomo and Reliance Jio are among the exceptions that have to some extent decoupled digital services from their own networks and established broader brand relationships with users. But even those innovators' services are relying on the first-generation cloud architectures that Caroline referred to, and that has limited their ability to scale up their services or build broad ecosystems. The services they offer remain relatively few in number, static and slow to be modified or replaced. The convergence of network and application microservices will provide the opportunity to address a huge variety of industries and customer bases with an array of dynamic shape-shifting services. Operators may choose to provide platform services to enable a wide range of service providers, enterprises and other operators, harnessing capabilities of the cloud-native 5G core, such as end-to-end dynamic slicing. Or they may build on the limited models pioneered by Docomo and others and aim to be service providers themselves, at least in selected verticals. Moving up the stack, however, is challenging because it exposes operators to new competition. In the platform layer, they will need to compete or partner with public cloud providers, such as Microsoft Azure, complete with its own 5G core now, courtesy of buying Affirmed and Metaswitch. And they may even compete with their own vendors. Nokia's direct-to-enterprise strategy is certainly a taste of things to come. While in the services layer, there will be myriad organizations competing on the basis of innovation, pricing, brand, and so on. And it may be hard for an operator, especially in markets where they've lost the primary consumer brand relationship to Google or Apple, to be noticed in the crowd. However, there are opportunities in these layers for those operators that are prepared to address the market in an entirely different way. This is a world, as Caroline has shown us, where many stakeholders can co-create applications, with the cloud-native network acting as a peer that can be supported by operators' edge-native cloud environments. Each value chain, or mixture of them, will require different combinations of partners and capabilities, and those need to be cultivated now, while operators still have something attractive to offer potentially powerful partners, i.e. their 5G networks. The role that an operator chooses to target in that value chain will shape all the decisions I outlined earlier. It will decide the ecosystems that an operator needs to build or join, and it will decide the technologies that the operator needs to prioritize for investment and ownership. This is an important point. The days of ownership economics, in which operators sought to own almost every element of their networks and IT platforms, are ending. The cost of each operator building its own entire 5G platform would make return on investment unachievable for the average telco. The 5G era is one in which operators identify the network elements that are most strategic to their business model and which they need to own and control, while others can be obtained from wholesale partners or shared with other operators. Sharing of passive infrastructure such as cell towers has become commonplace, of course. Sharing of active RANs and reliance on third-party cloud platforms, such as the recent AT&T-Microsoft alliance, is emerging as a sign of a more cooperative model in which investments and operations span multiple industries, not just multiple telcos. Investing only selectively in fully owned assets will help to ensure that the new cloud-native networks can be cost-justified even to those cautious boards. Introducing cloud-native networks will transform the cost base over time, but initially requires some significant new investment in infrastructure and skills, whether in-house or from partners. Cloud strategies that are primarily driven by cost efficiency will fail. To keep the cost of 5G stable, despite ballooning amounts of infrastructure, edge, cell sites, fibre, operators must achieve cost efficiency in a different way, and one that also supports the wider commercial and transformation strategies. Our modelling and forecasting of telecoms CapEx and OpEx scenarios in our Operator Investment Strategies programme has a heavy focus on the impact of this new selective ownership. The graph on the left shows the sum of the industry's spending on 5G era networks between 2018 and 2026, as it would look if operators continued with the same level of network ownership as in 4G, that's the control experiment, compared to the more selective approach of the cloud-native 5G operator. Cumulatively, that more agile approach to infrastructure will save the entire telecom sector almost $2 trillion between 2020 and 2030. But selective asset ownership must not be just about cost reduction any more than cloud transformation must be. It's about aligning the assets that the operator does own with its chosen role in the new value chain. If it's chosen the enhanced connectivity layer, it stands to reason that it will concentrate its investment on building the most capable and differentiated RAN. If it is targeting higher layers, the sliceable core, orchestration, and SDN will be among the assets to build and differentiate, while there may be a strong case to share much of the connectivity itself or to rely on wholesalers. The graphs on the right show how different the CapEx and OpEx profiles of different operators look. The more digital players are not necessarily spending less, though they are usually less CapEx intensive than the infrastructure-centric players, but they are focusing their spending on different areas and ones that are critical to their chosen role. The infrastructure-centric operator, on the left, for instance, will typically spend almost 60% of its CapEx and OpEx on physical networks, underlying infrastructure and associated staff, compared to 30% for the operator on the right that is transforming itself into a cloud-native provider. That transformed operator will typically spend over half its CapEx and OpEx on software, platforms, orchestration, and cloud infrastructure to support its new role in the value chains. Our surveys of operators and other service providers always point to a major barrier to significant change, and that's the operator's own organisation and culture, which has often been built up over many decades. This, as much as the freedom to embrace new technologies without the challenges of integrating legacy networks, is what helps greenfield operators to leap ahead in the new edge-native world. Traditional operators have siloed organisations with fairly static roles and hierarchies for individuals and divisions. Even the convergence of networks and IT management, let alone underlying organisations, has been talked about for a decade but remains rare. Many operators with strong enterprise businesses say that these groups never speak to those responsible for 5G, and so the chance to steal a march in B2B 5G is wasted. How much more challenging it will be to create an organisation that optimally supports and enables convergence at a far more fundamental level between network services and application services, as Caroline has described. Some traditional operators are making efforts to break down walls and to take a more agile approach to their internal structures and their relationships with ecosystem partners and their vendors. The bid to leverage Open RAN architectures is just one sign of the attempt to shake up supply chains and approach procurement and partnership in a way that's appropriate to an agile, cloud-based world. In this world of ever-changing demands on hyper-connected, hyper-local 5G clouds, siloed teams and lengthy decision-making processes, as seen on the left, will fail to respond adequately, and the potential returns on a high-quality network will be squandered. The new organisation needs to have lean, cross-functional teams that make decisions rapidly, aided by AI, that automate many processes, that interlock with one another in a focused but flexible way, and that work with external partners and internal staff in the same holistic manner. Such organisations, as you can see pictured on the right, are a very big step from the silos of the typical telco, and powerful leadership will be required to coordinate and inspire all the functions, typically coming from a chief digital officer and/or a specific head of transformation. As in the network itself, so in the organisation. Operators will automate far more functions, and they will also entrust far more activities to external partners, increasing their access to a broad base of innovation and allocating costs efficiently. These will not be the supplier relationships of old, defined by a long-term static contract based on an RFX that was years in the making. These must be fluid, dynamic, and on-demand relationships that can tap into the skills required at any particular time and place. A clear targeted role in the value chain, and an alignment of network investments, partners, and internal organisation with that targeted role, these are the essential ingredients of the 5G experiment. I'll now ask Caroline to sum up how we believe operators can maximise their chances of turning that great experiment into a successful business outcome in the coming years.
Thank you, Caroline. Well, no one can really predict the future. And though we are all reading the signals here as to the direction it might take, and we've sized the potential prize on offer, it's not at all clear yet how that prize can be won. As Caroline pointed out, the 5G network represents a much bigger change than other Gs, where the outcomes and risks were relatively well understood. The cloud-dominated landscape the 5G network is being deployed into is itself undergoing multiple experimental transitions. So given this high level of uncertainty, we recommend that operators accept that they must experiment and that they establish a continual process of testing different combinations of technologies and services to learn which yield the best results. Understanding the cloud and the network's role in a cloud-native world today and an edge-native world tomorrow will be a critical part of an operator's experimentation process. As I said, the 5G network provides operators with the opportunity to deeply master the software skills needed to build the future of connectivity beyond 5G, as well as the right mindset and culture to compete with the IT overlay network builders out there, which want operator networks to remain dumb pipe infrastructure they can ride across at minimal cost. And finally, Caroline has discussed the key decisions operators need to make and which will determine the success or failure of their 5G experiments. Decide on the role that makes the most sense for you in the emerging cloud-native value chain, and let that guide the scope of your experimentation, the ecosystems of partners you need to assemble, and the type of investments you're prepared to make, including, and perhaps most important of all, investment into changes to the culture and organization needed to make 5G successful first, as a dress rehearsal for end-to-end network transformation in future. Thank you for listening, and back to you, David.
Thanks, Caroline. So to finish, I'll just first of all say thank you to both Carolines for that fantastic presentation, and thank you to everyone who has attended. Now, before you go, I just wanted to remind you of a couple of things that you can do. You can access the useful resources, you can submit a question, and connect with the panelists via the console widgets. Now, lastly, please feel free to make your way back to the event homepage by clicking on the event homepage button, where you can select another session to enjoy. So I hope you have enjoyed this session, and we look forward to welcoming you to another very soon. Thanks again for attending. Take care.